It has been 2 years since the James Webb Space Telescope, operated by NASA, gave us a breathtaking first glimpse into the far reaches of our universe. This telescope, worth $10 billion, stands as the largest and most powerful one in space. After capturing stunning images, the James Webb Telescope revealed something that NASA had been concealing about Mercury. Following this discovery, the United States quickly halted the mission. This seemingly ordinary planet is far from what it seems. As it orbits close to our massive sun, Mercury's scorching landscape is interspersed with surprising phenomena, including sparkling diamonds. But beneath its glittering surface lies an enormous and mysterious core that challenges our previous scientific knowledge. What other hidden truths lie behind these astounding revelations? Let's explore the discoveries that might dramatically alter how we understand the planet. Although Mercury may seem small when compared to the Sun, don't be misled by its size. Beneath its intense, boiling surface lies a wealth of incredible secrets. Recently, probes from Earth uncovered a startling revelation. Mercury's surface is littered with diamonds. These remarkable gems exist on one of the hottest planets in our solar system. But this is just the beginning. As we dig deeper, we learn that Mercury's core is both bizarre and exceptionally large. These findings raise crucial questions. What sets Mercury apart from its neighboring planets, and what other hidden phenomena might it conceal? The Mariner 10 spacecraft was the first to reach Mercury, making it a pioneer in space exploration. It returned the initial close-up photographs, revealing a planet marked by craters and strange ridges, much like our moon. This mission shattered long-standing assumptions about Mercury's makeup, showing that it has a rugged surface, an unexpectedly powerful magnetic field, and a core larger than previously imagined. However, this wasn't the most shocking revelation. 3 decades later, the Messenger mission came along and transformed our understanding of Mercury. Unlike Mariner 10, Messenger was designed to orbit Mercury, enabling detailed, long-term observations. It captured nearly 200,000 images, significantly expanding our knowledge of the planet and uncovering previously hidden regions of Mercury. Among Messenger's key findings was the discovery of unusually high concentrations of calcium and magnesium on Mercury's darker side. This sparked interest in the natural processes that might be responsible for the elevated levels of these elements. Additionally, scientists were surprised to learn that, unlike other planets in the solar system, Mercury's magnetic field was surprisingly stronger in its northern hemisphere. These findings forced scientists to rethink their previous assumptions about Mercury's interior and its geological evolution. On Earth, the movement of molten iron within the core is primarily responsible for generating magnetic fields. However, Mercury exhibits a unique kind of magnetic activity due to its distinct internal structure. But what else sets Mercury apart? Apart from its craters and ridges, the planet's surface experiences extreme weather. During the day, temperatures can soar to a scorching 86 degrees Fahrenheit, hot enough to melt lead. Yet at night, the temperature plummets to around -292 degrees Fahrenheit. Mercury's thin atmosphere does little to retain heat or regulate temperature, resulting in dramatic temperature shifts. But there's more to Mercury than just its extreme heat. Recent investigations have uncovered some surprising features. Data from the Messenger mission in 2012 revealed evidence of ancient explosive eruptions and signs of ongoing volcanic activity. This challenged the earlier theory that Mercury had been geologically inactive for billions of years. Then, in 2020, scientists made another fascinating discovery. They found that portions of Mercury's permanently shadowed polar craters contain water ice. Despite Mercury's proximity to the Sun, these regions remain cold enough to preserve frozen water because they are shielded from sunlight. This discovery raised new questions about whether Mercury could support primitive life forms in these frozen regions, much like Earth's most inhospitable environments. This question has intriguing implications for our understanding of the potential for life to survive on other planets, especially in environments that might seem hostile to us. But the story doesn't stop there. In 2018, in collaboration with the Japan Aerospace Exploration Agency, the European Space Agency launched the Bepicolombo spacecraft toward Mercury. It is expected to reach the planet by 2025. Once there, BepiColombo will start gathering extensive data about Mercury, including its surface composition and geological history. Interestingly, despite being so close to the Sun, Mercury has both water ice and a strong magnetic field. What might surprise you even more is that a day on Mercury is actually longer than its year. When we think of a planet, we typically imagine it orbiting the Sun once every year and rotating on its axis once per day. However, Mercury defies this expectation. A day on Mercury, or a full rotation on its axis, takes around 176 Earth days, while its orbit around the Sun takes only 88 Earth days. This means a year on Mercury lasts only half as long as a day. This results in some very peculiar phenomena. As seen from Mercury, the Sun rises and gradually grows larger across the sky. But then, something strange happens. The Sun appears to pause, reverse its path, and then continue on its journey. This is due to Mercury's slow rotation compared to its rapid orbit around the Sun. But why does Mercury rotate so slowly? The answer lies in tidal locking. Over billions of years, the Sun's gravitational pull has gradually slowed down Mercury's rotation. Mercury is in a 3:2 spin-orbit resonance, which means that it completes 3 rotations on its axis for every 2 orbits around the Sun. This creates a unique day-night cycle that contributes to extreme temperature variations. On the planet's sun-facing side, temperatures can reach scorching highs, while on the opposite side, long stretches of icy darkness persist. These temperature swings are among the most extreme in our solar system. It's important to note that Mercury doesn't have a traditional atmosphere like Earth. Instead, it has a very thin exosphere, which is so sparse that it continuously evaporates into space, replenished only occasionally by solar wind, radiation, and collisions with small space debris. Recent research has revealed some unexpected details about Mercury's exosphere. Data from the Messenger spacecraft in 2020 showed that scientists had previously underestimated the amount of water vapor in Mercury's exosphere. This water vapor likely forms when oxygen from Mercury's rocks interacts with hydrogen from the solar wind. Another astonishing feature of Mercury is the speed at which it orbits the Sun, especially when compared to its slow rotation on its axis. This strange combination has a significant impact on the planet's magnetic characteristics. Scientists were astounded to discover that Mercury has a strong magnetic field, despite its relatively small size and sluggish rotation. Further studies indicated that Mercury's unique spin and orbit, along with special movements within its liquid metallic core, contribute to the planet's magnetic field. However, it's important to note that Mercury's magnetic field is much weaker than Earth's. Mercury's surface is protected from the harsh solar wind by its magnetic field, but without this shield, the Sun's solar wind would further thin the already sparse exosphere. Mercury's slow spin and rapid orbit create fascinating conditions on the planet's surface. For instance, Mercury has regions known as hot poles, where the Sun appears to hover in the sky for an extended period, causing extreme heat. On the other hand, areas near Mercury's poles remain perpetually dark, keeping them cold enough for ice to survive, despite the planet's closeness to the Sun. Mercury's slow rotation and rapid orbit present challenges for space exploration. Due to its fast orbit, spacecraft must use intricate navigational techniques, including multiple flybys of Venus and Mercury itself, to slow down enough to enter orbit around the planet. The BepiColombo mission, launched in 2018, is currently utilizing these flybys to adjust its trajectory and speed. Once it arrives in 2025, BepiColombo will need to carefully manage its power and temperature systems to survive Mercury's peculiar day-night cycle. Mercury continues to astound scientists, offering new clues about its evolution and the formation of planets. Research suggests that Mercury may have originally spun more rapidly before gradually slowing down due to the Sun's gravitational pull and possible impacts from other celestial bodies. This discovery provides more insight into the history of Mercury and the forces that shape planetary evolution. As scientists continue to explore, new questions arise about Mercury's core, surface, and the unique forces that have shaped it. The more we learn, the more we realize how much Mercury challenges our understanding of planetary science. Mercury remains the smallest planet in our solar system, yet it holds many secrets that continue to intrigue scientists. One of the most remarkable features of Mercury is its gigantic core. According to planetary scientist Dr. Nancy Chabot, Mercury's core makes up about 85% of the planet's total volume. In contrast, Earth's core accounts for just 15% of its total mass. This raises an important question. Why is Mercury's core so enormous? One popular theory suggests that Mercury was once much larger but lost much of its outer layers due to a massive collision early in the history of the solar system. This theory, known as the giant impact hypothesis, proposes that a giant object collided with Mercury, stripping away its outer layers and leaving behind the dense iron-rich core that we observe today. Mercury's magnetic field, though weak, is also a source of fascination. Despite its small size and slow rotation, scientists were surprised to find that the planet has a global magnetic field, unlike Venus and Mars. This discovery, made by NASA's Messenger spacecraft, led to further investigations. Researchers also discovered that Mercury's magnetic field is uneven. Dr. Katherine Johnson and her team found that Mercury's radius is displaced by about 20%, which may be linked to variations in the planet's crust and the way heat is released from its core. In 2020, further studies revealed that volatile substances, such as sulfur, potassium, and sodium, are present on Mercury's surface. These findings added to the growing body of knowledge about Mercury, making it one of the most intriguing planets in our solar system. As we continue to explore, Mercury's mysteries continue to unfold, challenging our understanding of planetary formation and evolution. The mysteries surrounding Mercury continue to captivate scientists as researchers dive into its numerous enigmas. While some discoveries offer glimpses into what the planet may hold, many questions remain unanswered. One of the most intriguing aspects of Mercury is the presence of compounds that, at such high temperatures, would typically vaporize. Dr. Patrick Peplowski from the Johns Hopkins Applied Physics Laboratory has put forward the theory that comets or asteroids might have delivered these materials much later in Mercury's formation. One of the most exciting revelations about Mercury is the existence of water ice in the permanently shadowed craters at the planet's poles, a discovery made possible by the efforts of Dr. Nancy Chabot. These craters are so cold that the ice remains frozen, and the possibility of complex carbon molecules, similar to those that may have sparked life on Earth, being present there adds another layer of intrigue. Could Mercury, with its extreme conditions, offer clues to the origins of life in our solar system? When it comes to Mercury's geology, there have been more surprises. Once thought to be geologically inactive for eons, new data from NASA's Messenger spacecraft points to recent volcanic activity. Dr. David Ree from the Open University in the UK uncovered tiny, shiny volcanic vents, known as hollows, which offer insights into the planet's ongoing geological processes. These hollows, part of the planet's surface features, suggest Mercury's geology may still be evolving. Another peculiar aspect of Mercury is its chaotic heart, a vast, disordered region near the southern pole, first identified during the 1970s Mariner 10 mission. Dr. Thomas Waters of the Smithsonian Institution proposes that large earthquakes, triggered by the sun's gravitational pull, may have shaped this landscape. Mercury's internal structure is just as fascinating. Using data from the Messenger mission, Dr. Amir Khan of the University of Zurich revealed that Mercury has a large solid inner core, surrounded by a liquid outer core, much like Earth. However, Mercury's inner core is much larger, which could explain its unique magnetic properties. This unexpected information challenges our understanding of planetary formation and evolution, showing that there are still many secrets hidden in the solar system. The Messenger mission also uncovered that Mercury has a thin mantle, just 260 miles, 420 kilometers, thick, compared to Earth's much thicker mantle. This thin mantle influences the planet's heat distribution and geological activity. Researchers found evidence of ancient volcanic activity beneath Mercury's surface, including shallow depressions called hollows that formed when volatile compounds near the surface evaporated. In 2020, scientists found signs of a large magma reservoir that once lay beneath Mercury's surface, shaping large, flat plains, particularly in the northern hemisphere. These volcanic plains, known as the Northern Volcanic Plains, were likely formed by massive lava flows early in Mercury's history. Further analysis of the MESSENGER data in 2022 revealed more mysteries, including hints of nitrogen trapped beneath the surface. This suggests that Mercury may have once had a denser atmosphere that was driven underground by the planet's extreme heat and relentless solar radiation. Another fascinating discovery involves the ice found in the permanently shadowed craters at Mercury's poles. This ice is shielded from the sun, remaining frozen despite the planet's proximity to the sun. Some of this ice could be relatively young, likely delivered by comets or asteroids over the past tens of millions of years. The possibility of organic compounds being present in these frozen regions raises more intriguing questions about the potential for life or its precursors to have existed on the planet. Mercury's geological history also shows signs of contraction as the planet cooled. Evidence of thrust faults, where portions of the crust are forced upward, provides insights into its past. Newer research suggests that Mercury might still be geologically active. A 2019 study found signs of ridges, tiny valleys formed by crystal straining near the planet's largest faults, indicating that the planet's crust is undergoing changes. Mercury's magnetic field is another area of interest, as it differs significantly from Earth's. While Earth's magnetic field is generated by molten iron in its outer core, scientists are investigating whether Mercury's field is powered by liquid metal circulating around its solid inner core. This mechanism could suggest that Mercury's interior is incredibly active, akin to that of other planets and stars. Furthermore, Mercury's crust is believed to contain numerous fractures and cracks, which could allow heat and even liquids to travel between layers. This theory raises the possibility that, despite Mercury's dry and desolate surface, there could be active processes occurring beneath the crust. Some scientists even speculate that there might be hidden water reservoirs deep within the planet, remnants of a time when Mercury had a more temperate environment. If such water exists, it could offer vital clues about Mercury's past and its potential for sustaining life. The exploration of Mercury's depths holds the promise of further revelations about the planet's history and its role in the solar system's formation. As scientists continue to study Mercury, they will gather crucial insights into the evolutionary history of rocky planets, and perhaps even uncover clues about the early solar system. With every new mission, the mysteries of Mercury grow deeper. Despite its small size and close proximity to the Sun, the planet remains a treasure trove of secrets, offering scientists a rare opportunity to study how the Sun affects planetary development. Exploring these depths could not only unveil Mercury's hidden past, but also enrich our understanding of planetary science, with Mercury playing a key role in unraveling the early history of our solar system. As we continue to explore Mercury, we must keep in mind that even though this planet is small, it still holds vital clues about the evolution of rocky planets. Its proximity to the Sun, unique magnetic field, and geological history all provide an extraordinary opportunity to learn about the early conditions of our solar system. Through ongoing missions, we may uncover even more secrets, such as the exact mechanisms behind its magnetic field or the nature of its interior activity. Scientists are particularly excited about the potential for discovering signs of ancient life or conditions that could have supported life in the past. The presence of water ice in Mercury's polar craters, combined with the discovery of organic compounds, suggests that the planet may have once had the necessary ingredients for life. This raises the possibility that comets or asteroids, which have delivered essential molecules to Mercury, might have also played a role in the development of life elsewhere in the solar system. Furthermore, Mercury's volcanic history, combined with the evidence of active fault lines, points to a planet that, while not entirely dormant, is still undergoing significant geological changes. The discovery of cracks in its crust and the suggestion that heat or water might move between the layers challenges the old assumption that Mercury's interior had cooled completely and ceased any geological activity. The ongoing investigations into the distribution of gases, such as nitrogen, beneath Mercury's surface are particularly intriguing. These gases could be remnants of a denser atmosphere that Mercury once had, before solar winds stripped it away. Understanding this process not only informs us about Mercury's past, but also provides a deeper understanding of how planetary atmospheres evolve, knowledge that can be applied to studying exoplanets or moons with similar characteristics. In many ways, Mercury stands as a reminder that even the smallest planets still have remarkable stories to tell. Its secrets may not only illuminate its own past, but also shed light on the processes that shaped the rest of the solar system. As we continue to probe Mercury's depths and surface, each new finding is a stepping stone toward understanding the broader cosmic narrative of planetary evolution. In conclusion, the study of Mercury holds immense significance in planetary research. While its surface may seem barren and hostile, the discoveries made thus far suggest a planet with a rich and dynamic history. Its magnetic field, geological processes, and potential for past water and life give us crucial insights into the workings of our solar system. As scientists dig deeper into Mercury's past and future, they may unlock answers that could have far-reaching implications for our understanding of planetary systems throughout the universe.